So in this lecture, we're going to look at some specific equations of ellipses. And we're going to look at how to get all the relevant information from it, how to get the location of the center, how to get the location of the focal points, how to get the A and B values. Those are the lengths of the semi-major and semi-minor axes. And then once we've got all that information, we'll do a quick sketch of the graph of the ellipse. Now, before I do that, I want to be really clear about what the difference is between A and B. Okay, so if we're looking at these two equations, and I've got their graphs here, the first thing I want you to focus on is the length of the axis in the x direction versus the y direction is based on the number under that variable. Okay, so looking at this first equation, the value under that x squared is 4 squared. So the length of the axis that's horizontal, that's parallel to the x-axis is 4. So that's this distance here. And the number under the y is 3. So the length of the axis, semi-axis really, that's parallel to the y-axis is 3. Now if you look at the other one, you notice they're reversed. The 4 is under the y, and this distance here on the y-axis is 4. And this number under the x is 3, so this distance here is 3. Okay, so which of these values is A and which is B? Because that's important for finding C, right, where the focal points are. So we need to know that. Looking at this first equation, A is equal to 4 and B is equal to 3. And looking at the second one, A is equal to 4 and B is equal to 3. A is the length of the semi-major axis, and that is always the bigger of the two numbers, regardless of where it is in the equation. B is always the length of the semi-minor axis, and that's always the smaller number, regardless of where it is in the equation. And so that's how I'm going to pull those A and B values when we're looking at the equations on the next couple of slides. So I've got two equations for us to look at on those slides. The first one is relatively straightforward. The equation is already in that x minus h squared over a squared plus so on form. So that one is like I said, straightforward. It's going to let us just kind of see how to get all the values that we need. The next one is a little more interesting. You'll see the ellipses in its general form, and we're going to have to get it into that useful form where everything is factored. So I got our first equation here. And what we want to do is we want to analyze this equation. When I say analyze an ellipse, that means I want to find these key points. I'm going to find the center, the length of the two semi-major axes of the semi-axes, the A and B values, and I'm going to find the location of the focal points. So the location of the center we can get really quickly. Remember the numerator here, this is x minus h squared and y minus k squared. So I can tell right away the center of my circle, of my ellipse, is at 1, comma, negative 2. All right, so to get A, remember that A comes from the bigger number in the denominator. So A squared is going to be 25, which means A is 5. And yes, I do just want the positive one. This A is the length of the semi-major axis. Since it's a length, I want that to just be a number. Then to get B, B squared is equal to the smaller number, that's 8, which means B is the square root of 8, that's 2 times the square root of 2. So this is approximately 2.8. So let me put that on my list over here. There we go, 2 square roots of 2, that's the square root of 8. And I'm going to come back to the focal point in a minute, because really that's enough for me to graph my circle. My center is, my ellipse, I keep saying circle, my ellipse. So this is, the center is here at 1, negative 2. And to get the y direction, how far to go up and down, that's going to be based on that a value, which is under the y squared. So I'm going to go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. And to see how far I need to go in the y direction, in the x direction, I'm going to look at the b value. 2.8, that's almost 3. So I'm going to go over 3 and back a little. And I'm going to go over 1, 2, 3 and back a little. And those are enough points that I can sketch the circle. Now, you got to kind of work with me. If you've watched me do this before, my art skills are pretty seriously limited, but yeah, that's not too bad. There's our ellipse. All right, so how can we find the focal point? Well, remember, for this, we need this equation that we derived earlier. C squared equals a squared minus b squared. So c squared, that's going to be 25 minus 8, which is 17. So c is the square root of 17, which is, I don't know, the square root of 16 is 4, and this is just a little more than that, so I'm going to say it's approximately 4. Okay, so where does that mean my focal points are? Well, remember, the focal points are on the major axis. The major axis is running up and down here. So let me put the coordinates of this center in. This is 1, -2. So to get the focal points, I'm going to go up 4 plus just a little bit. That's right about there. And I'm going to go down 4 plus a little bit, which is right about there. So there's where my focal points are. And this is why I even if I'm not asked to sketch the graph, I like to do it anyway. Because when you're trying to find this focal point, it's always, okay, well, is the x-coordinate the same as the one in the center, or is the y-coordinate the same as the center? Once you've graphed this, it's pretty clear what you're doing. The y-coordinate for both focal points is going to be 1. Did I say the y-coordinate? The x-coordinate of the focal points is going to be 1. And to get the y-coordinate, you just take the original value, go up that value of c, and down the value of c. And there's your focal points. So we'll go ahead and add them to my list here. And the way I usually write this, I'll do 1, comma, -2 plus or minus the square root of 17. And that's all the information I can get so far, right, from what we discussed already for this ellipse. So I want to do the same thing with this equation, but this one isn't in that nice factored form where I can just grab the a squared and b squared. Oh, but that's okay. We can get it there, and we're going to do something here that's very similar to what we did when we were working with the equation of a circle. First, I'm going to group the x and y parts together. So I'll do 4x squared plus 16x plus 9y squared minus 54y equals -16. Okay, now I'm gonna factor because I need to get rid of the 4 and the 9. So I'm going to make this 4 times x squared plus 4x, and I'm going to leave some space there because I'm going to add a number in, plus 9 times y squared minus 6y, and again I'm going to leave a space there, equals -16. So what do I have to add to turn these into perfect squares? For the first one, it's going to be 4 divided by 2 squared, which is 4. So that means I have to add 16 over here. Because remember, I didn't just add 4, I added 4 times 4. Right, now for the other part, I'm going to add -6 divided by 2 squared, which is 9. So again, I didn't add 9 there, right? I added 9 times 9, so I'll add 81 over here. And now I can factor this. This is 4 times x plus 2 squared plus 9 times y minus 3 squared equals 81. And then divide by 81, because remember in that equation we derived, there was a 1 on that right-hand side, and that's important. We have to have a 1 there before we can start grabbing a's and b's. So if I divide by 81, this becomes 4x plus 2 squared over 81 plus 9y minus 3 squared over 81 equals 1. All right, I'm going to go a little further. I'm going to reduce this fraction over here on the second part and make this y minus 3 squared over 9 equals 1. And now remember what our equation looks like. It's x minus h squared over a squared. No number out here in front. So what I'm going to do is I'm going to rewrite it this way. I'm going to make this x plus 2 squared over 81 fourths. And now it really does look like that equation that we derived, right? From this form, I can get all the bits and pieces that I need. I'm going to do that on the next slide because I ran out of room. Okay, so I've got my equation here, right? That's just where we left off. And now it's in a form where I can get all this useful information from. So the first thing I see right off the top is that the center is at -2, comma 3. That's right here. And so what are A and B? Well, 81 fourths is in the neighborhood of 20. So that is definitely bigger than 9. So this one is going to be A. A squared is 81 fourths, which means A is 9 halves. That's going to be in the X direction, right? Because it's under the X part. So that's 4.5. So I'm going to go 1, 2, 3, 4 and a half. And I'm going to go 1, 2, 3, 4 and a half. Then B squared is going to be 9. So B is equal to 3. And that's the Y direction. So I'm going to go up 1, 2, 3, down 1, 2, 3. And that's all I need for my sketch, right? There's, got a little dubious there, right? Yeah, that's more or less what my ellipse looks like. All right, but we do still need to find the focal point. All right, so to do that, we're going to use that same equation, c squared equals a squared minus b squared. A squared was 81 fourths. B squared was 9. Okay, 9, that's 36 fourths. 81 minus 36, that's 45. 45 fourths. I'm checking that in my head real quick. Yes. So C is the square root of 45 fourths, which is 45, that's 9 times 5. So that's 3 times the square root of 5. And the square root of 4, square root of 4 is 2. Okay, so what's the square root of 5? I don't know. It's fairly close to 2, just a little bit bigger than 2. So this is approximately 3. All right, so now I know where my focal points are. I'm going to start at my center. I'm going to go 1, 2, 3 units to the right. I'm going to go 1, 2, 3 units to the left. And I really should label these. Let's say that's F1. This one is F2. And that's going to be C. All right, so what are the coordinates of those focal points? Well, you can see from the diagram, their y coordinates are all the same. Their y coordinates are all 3, and it's the x coordinates that are different. It's -2 plus or minus 3 halves square root of 5. So there are my focal points. So before we go on, there is one key point I want to make here. Right? I've got these two equations here. You notice they are practically identical. Right? The only thing distinguishing them is this x squared coefficient. In the first equation, the x squared coefficient and the y squared coefficient are different. That's what tells me that that equation is the equation of an ellipse. Right, then down here in the second one, those two coefficients are the same. Right, because they're the same, this must be the equation of a circle. Because I can get rid of them. Right? If you really wanted it to look like the equation of a circle, x squared plus y squared plus other stuff, just divide through by 9. And those coefficients go away. Right, now I do need to qualify this ellipse one just a little more. These two numbers are different and they both have the same sign. They're both positive. If they had had different signs, then we would get something else. That would be the equation of a hyperbola, and that's the next conic section we're going to talk about. So if you're following along in the conic sections lecture, that's where we're going to go next. If you're following along in the analytic geometry course, then we still have a little bit further to go. We've got a few more things to derive about these ellipses.